Hi friends, in this video we are going to see the statistical inferences continuation with our previous video. And in this video we are going to see with the statistical inferences such as correlation coefficients, covariance matrix and the hypothesis testing. So first we will see about the correlation coefficient. What is meant by that correlation coefficients? That are used to measure the relationship between your two variables. So sometimes in your data set, one variable is depend on the another variable. So you want to know which variable depends on the another variable and also in how much it is related with another variable. So it will provide a measure that how much strong relationship between two variables in your data set. And this will be related with the values with -1 to 1. It represents +1 means it is a strong positive relationship. So when it is a positive symbol, it is a positive relationship. And it is negative, then it is a negative relationship. Or positive correlation, negative correlation. So if the value 1 indicates it is a strong positive relationship and -1 indicates it is a strong negative relationship. And this value represents it is a positive relationship, but it is not very strong. And it is a negative relationship, but it is a medium negative relationship. It is not a strong negative relationship. And the 0 indicates there are no relation at all between that two variables. And here I have a variable x and here I have a variable y. For example, I am having the age of the car here and here I am having the maintenance price of the car. So generally the car age increases, the maintenance cost also increases. But if I come here, it is the x-axis which containing the age of the car. And when the age of the car increases, generally the selling price of the car decreases. So that will give the positive correlation and negative correlation. And then this figures represents it is a perfect positive correlation and this is a strong positive correlation. And here it is a positive correlation only, but it is a weak one. And again we have a weak negative correlation, strong negative correlation and perfect negative correlation. And in order to find out these correlation coefficients, basically we use two different formulas. One is called as Pearson correlation coefficient and another one is called as Spearman rank correlation coefficient. By using these formulas, we are going to find out the correlation coefficient between two different variables to indicate whether that two variables are how much related with each other. What is the relationship between that two variables? And this Pearson correlation coefficient is otherwise called as Pearson correlation coefficient or Pearson's R correlation coefficient, which is defined in terms of these are all statistical methods which is used to infer the relation between two variables and it will measure the strength of the relationship between the two variables and its association between them. So these are the various formulas that you can use it to calculate the Pearson correlation coefficient, but basically the Pearson correlation coefficient is calculated based on the covariance. And you know what is meant by covariance, that is also provide the relationship between the variable but only the direction, either plus or minus, but it won't specify how much strong the relation is. This Pearson coefficient is calculated based on covariance and the standard deviation. And when you see in the websites, you may have the formulas with different variation because when you apply the covariance formula and you will get the two different representation of that. So this also yield the same value and this also yield the same value. But basically the Pearson correlation coefficient is calculated based on the covariance. So covariance is nothing but it is a measurement which provide the relationship between the two variables, but it specify only the direction, whether it is positive correlation or negative correlation, but it won't indicate the strength or dependency of the correlation. And first we'll see with the Pearson correlation coefficient. So here I have the first variable, maybe I have the two variables which may represents the height and the another variable will represents the weight. for example. Okay, so I want to identify how the variable x and y are related to each other. To find the relationship or the correlation coefficient, we are using the Pearson's correlation coefficient formula. To do that, I am using this formula. So to calculate that, I am finding the mean of that. For x, I am calculating the mean, and for the y, I am calculating the mean. Then I am doing the calculation of x minus x dash. That is the first thing for every data points, and then y minus y dash, that is for every data point. And then we need to calculate the formula for xi minus x dash the whole square, and that will be calculated here. For this x minus x dash, the square values are calculated here. And once it is calculated, we need to get the multiplication of this, and that we are calculating here. So I have put it in a tabular column, and for every data I have given with x and y, I have calculated the informations needed for my correlation coefficient formula. And once it is done, for this x minus x bar the whole square, we need to calculate the square root, and the summation of that you need to calculate the square root, that is your standard deviation of this. And like that, for this yi minus y dash, the square root, we need to calculate the standard deviation, that is the square root. And after doing that, we need to apply in the formula. So we have xi minus x bar, yi minus y bar, the summation. So that value is 478 divided by the square root of this xi minus xi the whole square, and that is 35.22546, and y minus y bar the whole square summation with the square root, and that will give the 25.6125. That will yield with the relationship with the correlation coefficient of 0.529809. So it represents, it is a positive correlation, but it is not nearest to 1 to represent it's a strong. Okay, so it is a medium positive correlation coefficient between these two variables. So we can tell the x and y are positively correlated with less strong between the relationship between them. So that you need to find out with the Pearson coefficient. And the next way to find out the correlation coefficient is by using the Spearman rank correlation coefficient. And here it is a non-parametric. Why it is non-parametric? We are not going to calculate mean, median, or we are not going to calculate the variance, standard deviation. Okay, nothing we are going to calculate. Instead of doing that, what we are going to do is we are going to apply a ranking concept. Okay, so Spearman is working based on the ranking concept. So this is my first input. For that I am putting a ranking. So for 21, the rank 1, and for the highest value, the rank is 6. Like that for y also, we are putting the ranking. The highest value is given with the rank 6, and the lowest value is given with the rank 1. After doing the ranking, we are finding the difference between the rank, and that difference we are doing the square, that will give the minus 2 the whole square. So that will give 4. So like that, we are calculating the relationship between the variables based on its rank. That will give how much it is correlated with one variable to the another variable. So we are calculating the difference between the rank. So now 1 minus 6 into the difference is 10 divided by the total number of inputs for my data is 6 square minus 1. So this will yield me the result of 0.714286. So this is again confirming me it is a positive correlation. So that is a positive correlation between the variable x and the y. And why we need to use this Pearson or Spearman? Okay, in which situation you need to use Pearson coefficient correlation or Spearman correlation coefficient? So the fundamental difference between these two are, generally the Pearson coefficient will work only for linear relationship between the data. We can see this is the example. If your data is having a linear relationship, a change in x linearly affecting the change in y, then you can go with the Pearson correlation coefficient. But when the Spearman coefficient, you see it is monotonic relationship. It is not a linear, but it is an increasing relationship, but it is not in a linear manner. So in that situation, we need to use with the Spearman coefficient. The another one difference, the Pearson will work with the raw data value. In the input data value, you calculate the mean, you calculate the variance, you calculate the standard deviation. So all the things we are calculating. So it is work based on the Pearson coefficient. But for Spearman, we are not working with the data. We are working with the rank of the corresponding data. So this will be giving you the information how you can find out the correlation between two variables. And for the corresponding Python demo, I'm having the Jupyter notebook. And in order to calculate the Pearson and Spearman coefficient, that is a statistical inferences. So we need to import the statistical library stats. In that we need to use with the Pearson R coefficient and the Spearman R coefficient. And these are the two data I'm having. So I have the subject marks, 6 subject marks, 6 marks for a particular subject, 2 subjects. For example, it may be physics and this may be maths. So I need to find out the correlation between these two subjects. And to find out or to see how it is correlated, so I am running the code. So I can able to see, I have plotted it so that I can check that yes, there is a linear relationship between, because when the x increase, there may be some increase in the y. So it may be a positive correlation. So by plotting, I get some idea how the data are available. To confirm statistically, I am going to calculate with the correlation coefficient. First, I am going to do with the Pearson correlation coefficient. And this correlation coefficient, you can use SciPy library, you can use NumPy library, you can use Pandas to calculate it. So here I have given 2 libraries. One is how to use with SciPy and how to use with Pandas. So when you use with SciPy, okay, so already we have imported the Pearson library and the Spearman library. So we need to pass the 2 variables to whom you need to calculate the correlation coefficient. So when you pass it and run it, so you will get the correlation coefficient value. So it is a positive correlation. It's conforming to you. And when you want to calculate the Spearman, you need to call the function Spearman. So based on the Spearman coefficient, I pass x and y variables. So I can able to know the variable x and y are positively correlated with the correlation coefficient value of 0.714. The same thing I am going to confirm with my Pandas library. So as you know, if I want to use with Pandas, you need to import the Pandas first. So Pandas, you cannot directly work with arrays, so that it need to be converted either as a series or it is a data frame. So whatever data I am having, that I am converting as a series. Series is a one-dimensional array. Similar to one-dimensional array, we are converting the input into a series using the Pandas library. After doing that, we have a function called as CORR. So in order to calculate the correlation between the variable x and y, so x dot correlation of y, then you need to pass which correlation coefficient method you need to use. If I specify method is Pearson, it will calculate the Pearson coefficient. If I pass Spearman, then the value will calculate it based on the Spearman correlation coefficient. So I can calculate the correlation coefficients either by using the SciPy library or by using the Pandas library. But you need to remember, when you use Pandas, the input can be a series or a data frame. Use the CORR function, CORR function. So x dot correlation of y. You specify the method by using which method you need to find the correlation coefficient. And now we will move to the next thing, that is how you can find out the covariance matrix. Okay. So since you know covariance, because correlation is calculated based on covariance. So covariance specify the variance between the variables. So it will give only the direction that specify how one variable is related to another variable, either in positively related or negatively correlated. So it will be represented as a matrix. Okay. So it is again called as variance covariance matrix, and it is a square matrix. So it provides the covariance between each pair of values. So previously correlation coefficient, we are calculating the correlation between two variables. But now the covariance will provide the variance between all two pair of the elements available in your data. Again, I told it will give only the direction, whether it is positive correlated or negative correlated, but it won't specify how strong it is correlated. And in the covariance matrix, so this is my input. I have three variables: age, experience and salary. So I need to find out the correlation between every pair: age to experience, then age to salary, then experience to age. Already I have calculated this, both are same, and I need to find out experience to salary. So in my x-axis all the three variables will be there, and in my y-axis, so it is a matrix, square matrix, and it's also symmetric matrix. So if you see here, this is diagonal. So whatever you have here, this is available here. Whatever you have here, okay, this is a symmetric matrix. So what it provides, it is a correlation between every two pair. What is the correlation between the age variable? That is this. What is the correlation between age and experience? If I go with age and experience, it is a positive correlation. What is the correlation between age and salary? So it is also again a positive correlation. So every correlation value, that is the how the variables are correlated with each other, that will be given here. Okay, and here this diagonal values, all the diagonal values give the variance, and all the other remaining values will give the covariance. What it means, because this I am calculating age to age, this I am calculating for experience to experience, this I am calculating for salary to salary, so it is a variance. And here I am calculating age and experience, age and salary, so two variables are related together, so it is called as covariance. How to calculate the covariance? So already we know how to calculate the covariance, because our correlation coefficient also we have used these covariance. Okay, so covariance, so by using the covariance we have calculated these informations. Okay, so now we will, so actually covariance will be calculated as x minus x bar and then y minus y bar divided by n, so the summation. Okay, so that only have calculated with every pair of two variables, how it is variant to each other. So you define only the direction, whether it is positive or negative. Using this covariance, further you can calculate your correlation coefficient. Okay, so now we'll see how to do this with Python coding. So now we'll go here. So correlation coefficient also, sorry, covariance matrix you can calculate with pandas, and also I have calculated with NumPy. Okay, so first I will go with pandas. So whatever data I am having, I am storing as a data frame. So I have age, experience, salary. So since you know I have an age, when the age increase, the experience get increased. When the age experience get increased, the salary also increased. But here I have given when the experience increased, I am providing a negative correlation, that is the salary is decreasing. So by using this COV function, you can find out the covariance matrix. So when you run it, you are getting here. So this diagonal values represents the variance, age to age variance, experience to experience variance. But this value gives you the information that how it is correlated between age and experience, age and salary. So since you know when the age increase, the experiences increase. So it is a positive direction correlation. But how much it is correlated, how strongly correlated, we are not giving. We are giving the variation between age and experience. That is, it is called as covariance. And then how the age and salary is related. When the age increases, actually my salary get decrease. So here this negative represents there is a negative correlation between age and salary. The same problem I have made it with positive increase. When the age increase, experience increase. When the age increase, salary also increase. So now when you do with the covariance matrix, you see here everything is positive. When the age increase, experiences increase. when the age increase, salary is increase. So whatever data given to you, you form in a data frame, then just call COV. So it will display you the covariance matrix to you. And the same thing I can get through NumPy. Okay. So I use with the three different information. So first one is my age. Next one is the experience. And the third one is the salary. So all the three I need to form like a multi-dimensional array using the NumPy. After doing that, just same as you call the covariance which is available in your NumPy. So that will give you in terms of exponential format. Again, you see here it is the correlation of 3.63. It is plus 0.1. So it is actually 36.3. And this is 24.1. And this is 45.8. Okay, so it is again showing you a positive correlation with your inputs. So I think you have get clear idea that how you can calculate the covariance matrix either by using the NumPy or by using the pandas. And next we will move to the next thing which is called as a hypothesis testing. That is also another one way of statistical inference. You can do it. And what is meant by hypothesis testing? So since you know that statistical inference means you do some experiments in your sample. Based on that, you are getting the inference about your population. So when you do some experiments, you are writing some claims. So that claim need to be proved or tested. And for that only, we are using the hypothesis testing. The claim, whatever you are telling about that experiment, that is called as hypothesis. So you need to prove that claim. To do that, we need some statistical experiments that is called as hypothesis testing. So hypothesis testing is a form of statistical inference that will derive some conclusion about your population based on the sample. So when you do with hypothesis testing, so you are testing your result of your survey to see whether you are getting some meaningful result. Because when you want to get some opinion about your entire population, we cannot go and ask every person of your population. So what you do, you take some sample and you do the experiment on the sample. Okay, so finally you are telling your success in that sample so that it will be successful for the population. But how much it is success? So that thing you need to prove by using the hypothesis testing. So hypothesis is nothing but a claim about a particular property. Hypothesis testing is nothing but you are validating that particular claim of the experiment. So when you use with hypothesis testing and when you need to write the hypothesis, that is the claim. So there are two types of hypothesis. One is called as null hypothesis and another one is called as alternative hypothesis. So null hypothesis is the assumption about the population. Parameter means population. So assumption about your population. And alternative means it is opposite to the null population. That is the null hypothesis. So I am telling that the average mean is 500. Average mean of the population is 500. So alternative is either the average mean is greater than 500 or the average mean is less than 500 or the average mean is not equal to 500. So this is my null hypothesis and these are my alternative hypothesis. So by using the hypothesis testing, I need to prove this or I need to accept any one of the hypothesis. So in order to do the Z test, first you need to, based on your problem, you need to form your null hypothesis and the alternative hypothesis. Then you need to define the level of significance. In my previous video, I have explained about the confidential level. How much level I can accept that particular thing. So based on the confidential level, I have calculated the confidential interval because you are calculating the sample mean. So you need to define how much it is accepted, how much interval it can take to accept your population mean. So that only you have your level of significance. So same thing, I am having my hypothesis about the sample. So I need to prove that it is possible to my population. So how much I can accept it? Okay, how much percentage of the thing what I am telling for my sample can be accepted for the population. So that level of significance you need to define it. And then you need to define the Z value. So based on this level of significance, you need to define the Z value, that is called as critical value. And then whatever inputs you are having, you have your mean of the population, you have your mean of the sample, and you have your standard deviation, and you have your number of samples. So based on that, your Z value get calculated. Okay. So whatever Z value, so this is your Z test statics calculation. So whatever Z value you calculated based on these available information, that you are comparing with the critical value. Okay. You are comparing the value whatever you calculated, you are comparing with, compare with the critical Z value. This is your calculated and this is your critical value. If your calculated value is greater than the critical value, then you can reject your null hypothesis. Okay. So based on the comparison, you can decide whether you can accept or reject your null hypothesis. So if your calculated value is greater than the available value, that is your calculated value is greater than the critical value, you can reject the null hypothesis, that is your HO. So it means that you are accepting your alternative hypothesis. If your Z calculated value is less than the Z critical, then you can accept the null hypothesis and you reject the alternative hypothesis. Okay, because you are having two claims. So you need to decide based on the Z test, you need to decide which claim you are going to accept and which claim you are going to reject. So how you are going to accept and reject, that is based on the Z calculated value and the Z critical value. This Z critical value is based on the level of significance. So how much percentage you are going to accept it and how much percentage you are going to reject it. So this level of significance, you need to decide your Z critical, and based on that it will be compared with your Z calculated. And now I have given you one example here. A principal of certain school claimed that their students are having above average intelligence. So this is their claim. Okay, this is their claim. They are telling their students are above the average intelligent. And to do this experiment, I cannot go to every student of the class or the school. I'm taking some 50 students from the school and calculating the average of 110. So what I got my sample mean is 110 and the number of students I have took is 50. And the mean population I got is 100. The mean population I got is 100. And the standard deviation I got is 15. So according to the claim, I am telling my school students are above average intelligence. But the population mean what I got is 100. So my null hypothesis, whatever availability now, available means from the population what I got is their average IQ value is only 100. So that is my null hypothesis. And what is my claim? My students are above average. My average itself I got only 100. But my claim is it is above average. So I have given it is greater than 100. So this is my null hypothesis and this is my alternate hypothesis. So now I am going to test it using the Z test, whether which claim I need to accept and which claim I need to reject. Okay, so I can take this claim, the maximum rejection ratio I can take with 5%. Okay, so that is my acceptance level, that is 5%, the level of significance. So the corresponding for every level of significance, so this is my alpha value. So if it is 0.05 significance level means it is mean that 95% confidential level. I have explained in my previous video. You can check my previous video that I have explained what is mean by the confidential level. So confidential level represents if I am repeating my experiment multiple times, 95% of the times I can claim I can get this result. So 95% I am having the confidence that that result can be accepted. So the rejection level is only 0.05. Okay. So based on the formula, I got my x dash, I got my n, I got my mu, and I got my sigma. So I apply all those things in the formula. So the calculated Z value, the Z calculated, I need to check with Z critical. So now my significance level is 0.05. So the corresponding critical value is 1.645. With the given values, I have calculated the Z. The Z value, whatever it is calculated, is the 4.71. So if my calculated value is greater than the Z critical value, okay, then I can reject the null hypothesis. So I can accept this alternative hypothesis. So whatever the principal claimed, it is correct. Their school students are above average and intelligent. So this claim now I am accepting. Okay. So this is the way how your experiments can be tested based on the samples. Whatever results you are arriving for the sample, that you need to prove for your population. So you need to do, or you need to write the claims. One will be the null hypothesis, another will be the alternative hypothesis. By using the Z test, you need to prove which hypothesis you need to accept and which hypothesis you need to reject it. So how I can do this? By using the Python programming. Same thing, I have given a question. So now I know from the question, I take all the values. X bar is my sample mean. So this is my sample mean. Then mu is my population mean. And then n is the number of samples. And this is my standard deviation. And now by using this, I can able to calculate my formula, that is Z, that is the Z calculated. Since my question, it represents 5% of significance, so I know about my Z score. The Z score is 1.96 from the table. You studied in your school, you have a Z table. So based on the Z table, for the 5% significance, the corresponding Z score is 1.96. So these are my claim, that is the mu value is equal to 100. The alternative is it is greater than the average intelligence, that is the greater than 100. So the calculated value is compared with the Z score. If it is greater, I can reject. If it is less, I can accept. So according to my condition, the calculated value becomes 4.71, which is greater than the 1.96. So automatically I am rejecting the null hypothesis, so that I am accepting the alternative hypothesis. So I think now you have get a clear idea what are the various statistical inferences you can do with your data set by using your statistics and probability. What are the things you can able to calculate? You can calculate the sample mean, you can calculate your predict your population or estimate your population mean, and you can find out the confidential interval, and you can do with your correlation coefficients calculation, then covariance matrix, and finally hypothesis testing. Thank you for listening.